Next, we'll have deleting a node from a linked list. Deleting node from a linked list. Now here, general case is there is a linked list. So there is a linked list. There is a starting point, as we have discussed earlier. There will be a starting reference and the value reference, value reference, value reference, value reference. Here is none. Now, general cases, there is a linked list and we delete a node which is there in the linked list. Delete a node which is there in the linked list. So this is one general case. Special case is one special case. There are going to be so many special cases. Special case is when a node is not there in the linked list. Node not there in the linked list. In the list. This is one special case. Second special case is a node to be deleted is at the end. Then node to be deleted is at the beginning. And one more special case is list is empty. List is empty. So these are so many special cases that are there in the linked list. We'll first take care of the generic case. So in generic case, there are already some nodes present and we have to delete a node which is already there in the linked list. So to delete the node, the first step what we have to do is read the data of the node to be deleted. Step 1. Read the data of the node to be deleted. To be deleted. This is step 1. Now steps 2 is reach the node to be deleted. So reach to the node to be deleted. So this is one important step and we'll be using loop for this. Suppose if I had to delete 15. So as usual, to traverse through the linked list, we'll be using current as a reference and checking whether the value is matching. If not, go to the next node. Not matching, go to the next node. Matching. Now current is referring to this. Now this has to be deleted. So we have reached to the node to be deleted. Now to delete this, the important thing is this node needs to be bypassed. So now we have to remove this node from the linked list. So to remove this node from the linked list, the reference to the node is present in the previous, and that previous node reference should be made to the next node of the current node to be deleted. This is how we have to do it. That means we have to bypass this. Now the important thing is when we keep on traverse through the linked list and reach the node to be deleted, we have to bypass the node to be deleted, but to bypass the node which needs to be deleted, we require the reference of the previous node also, because modification to the previous node reference we have to make. So here, because we require the node that is there previous to the current node, so we require two references which is running through the list. Current will be referring to the current node and previous node is referring to the node which is present before the current node. So this is uh, the logic we had to write. Now, initially to start with, both current and previous will be pointing to the first node, and when matching is not there, then when no matching is there, so move current into previous. Now the current node becomes the previous node. Sorry, current node becomes the previous node, and the next node becomes the current next. So this is the logic to run through. So the important thing is we require to reach the node, we require current node. Along with current node, we require the previous node, so that we can bypass the current node. This is the logic, and but it is not complete. This is to start with the deletion. I'm giving this, so I'll write the logic for that. So to write the logic, I'll first take the code. So here I'll say insert after given node, we'll see little later. First, let me complete delete. So define delete node, and we require self. And the first thing is we have to read the data of the node to be deleted. So this is the first thing. And before that, before we read anything, to clear the empty list. So if empty list is if there is empty list, we should simply stop the deletion. So what I'll do is, if self dot, one special case we are taking care here, start self dot start equals to none. So what I'll do is I'll say print list is empty, and I'll stop. I'll not further move, so I'll say return. So if the list is not empty, I'll read the data. And to after we read the data, I told you there will be current and previous, which will be in the beginning pointing to the first node. So I'll say current equals to self dot start, so it is pointing to the first node, and previous equals to self dot start. Now, what I have to do here is we have to run through till we find the required node. So the required node, how it is found, what is the condition? If current dot data not equals to data, as long as it is not matching, I'll keep on proceed. So what I'll do, I'll move before I move the current, I'll make previous follow current, then current equals to current next. Now this is the logic to reach there. So up to here we have discussed. Now after we reach this, now to bypass, what we have to, this is the logic to reach. So if current data is not matching with the node of the data of the node to be deleted, then move current. But before we move current, make previous follow current. So that's what we have done. After we reach the required node, so after we reach the required node, that means I have to delete 15. Current will be referring to this, and previous will be referring to this. Now I have to bypass. To bypass, what I have to do, I can simply say previous dot next equals to current dot next. So if I write previous dot next equals to current dot next, it is bypassed. So that is the simple logic. So to bypass, what I'll be doing is, so here this loop or traverse till required node is found. Now here we are assuming that the node is found, but it is not necessary. So after required node is found, so what we have to do is bypass current node. So to bypass current node, so what we'll be doing is previous dot next equals to current dot next. Previous dot next equals to current dot next. So that is the statement we write. So it is bypassed. So this is a simple case, but it is not necessary that it works always. Now we'll see when the node is there. Before we proceed, I want to execute this. Then we see how it is bypassed. But it is not sure that it will work for all cases. So because we have not taken care of the special cases, now I'll execute this. I'll execute this. Then I'll execute this. So here I have to add calling that I'm doing mistake here. So I'll take this option. If option equals to 4, we have to delete a node. Option equals to 4. So what we'll do is a list dot delete node. So I'm deleting the node. So now I'll execute this. So I'll execute this. Now one I'll insert at the beginning. So 10 I'll keep. So when I display insert, the 10 is inserted successfully. So 5. So 10 it is displayed. Then next insert at the end. So 20. So 5 it is 10 20. So 5 10 20. Now insert at the beginning 25. Now 25 10 20. If I display 25 10 20. Now if I want to now I want to delete 10. So I'll delete 10, enter data to insert. So there the message I have to modify, delete node. So 10, if I delete, it will be deleted. Now we check whether 10 is deleted or not. So 25 20 it is deleted. So it is working fine, but it is not necessary that it works for all. So it is working fine when the node is present at the somewhere in the middle of the list. Okay. So here one message delete, enter data to delete, data of the node to delete. Now one special case here, one special case we have already taken care, which is list is empty. So list is empty, we have taken care, self dot start none, list is empty. So when list is empty, when we try to delete a node when the list is empty, it will not allow. So I'll try to execute this. We'll try to check that case when list is empty. If I try to delete, what is going to happen, because I did not check that. So now the list is empty. I'll try to delete. So delete is 4. So it says list is empty. When I attempt to delete a node when the list is empty, it says list is empty. So it is working fine. One special case it is taken care. The other special case is when the node is not found. When the node is not found. So when the node is not found, it is going to create problem. So what we are doing, we are repeating the loop till the required node is found. So when the required node is found, when data current dot data equals to data, when it matches, it will the current will be referring to the node to be deleted. Then the loop is going to be terminated. Now when the the required, suppose if I take this linked list, I want to delete 40. So current is initially pointing to this, previous is pointing to this, 40 is not matching, then previous is pointing to this, current will point to this, then not matching, then previous points to this and current points to this, not matching, then previous points to this, current points to this, not matching, then current becomes none. So when the current becomes none, the required node is not found. But we are not taking that. We are not taking care of that. We are simply continuing, and we are saying previous dot next equals to current dot next. Then it is going to be a problem. So what happens is it is previous dot next equals to current dot next. Yeah, we'll check whether it is working fine or not. So when current here, the problem here is when the we reach the last node. So current is here, it's okay. Now current becomes none, but the loop is not going to be terminated because we are not checking for none. Then loop is repeated. Now current data not, when the node itself is not there, we are trying to check the data. It is going to be a problem. So we'll see what is going to happen. We'll see what is going to happen here. So there we have to write a special mechanism to check whether the we reach the last node without successful search. So suppose if I insert at beginning 1, I'll insert 10, I'll insert, then I'll insert at the end, insert at the end 20, I'll insert. Now 5, so it displays 10, 20, so it's okay. Now I'll try to delete the node which is not there. So 10, 20 is there, I'll try to delete 25. So it gives error because we are trying to check the data for the node which is not there. So none type object has no attribute data. So when current has become none, and when current has become none, we are checking current data here, current data not equals to data. So this is a problem. So to overcome this problem, what we have to do is we'll check whether if current is reached, current has reached the last node, means beyond the last node, or the required node is found. Till that time we have to continue. So what I have to do is I'll say current not equals to none. So current should not be none, means the list has is not exhausted, and data should not be matching. These two should be there. So once current is none, then it is the node is we can say the node is not there. The node is not there. We can display. So the last so this is one important thing. So what we here bypass current node if it is found. It is found. So how we check if current equals to none, equals to none, then the node required node is not found. So print we can say the node with data not found. So this is when this is a special case. If it is found when required node is not found. So this is when required node is not found. So this is how we will know whether the node is found. If the node is found, current will be holding the current will be referring to that node. If not found, then the list list will be exhausted and current will be beyond the list. It becomes none. So otherwise what you have to do is else previous equals to current action. Bypass the node. Bypass the node. Okay. This is we are taking one special case when the node is not found. So we'll check one two special cases we are taking when the list is empty. That special case we are taking care, and another is when the required node not found, also we are taking care. So that will check whether it is working fine or not. So we'll add the node, will execute it again and add at the beginning. So I'll say 10, sorry, option 1, so 10, option 2, 20, option 2, 30. So now it is 10, 20, 30. So 10, 20, 30. Now I'll try to delete 4, 25. Now it says, see what it says, the node with data 25 not found. It is instead of giving some error by the interpreter or compiler, we are giving our own error. We are saying that node with data 25 not found. So that special care is that special case is taken care. Okay, that is the important thing. Now when the node is node to be deleted is the last node. That is also one special case when node to be deleted is the last node. So there is no problem when node to be deleted is the last node, because I'll rewrite it so that the special cases what we have taken care, this special case node not in the list, that we have taken care, list is empty, we have taken care, node to be deleted is at the end, that we are going to take care now. Then we'll check whether node to be deleted is at the beginning is taken care or not. So this special case what we are going to take care here, we'll check. Now when we take this node, this is the linked list. Suppose this is 25, 10, 20. This is referring to this. This is referring to this. This is start. Now the special case, what we are taking care is, special case, what we have to take care is, the node to be deleted is at the end. So when node, that means I have to delete 20. I have to delete 20. When I have to delete 20, then current would be pointing to this node because this is node to be deleted, and previous would be pointing to this. Now what statements we are writing here to bypass? So this code is fine up to this. I'll take the delete part. So delete part. Now delete part. So here I'll take only this. I'll copy this here so that we'll analyze whether the code is working fine or not. So this is the code. What I'll do is I'll now what is happening? Previous equals to previous is pointing to this, current is pointing to this because the data 20. So initially current is pointing to this, previous is pointing to this, current data is 25, but data to be deleted is 20. Current becomes here current points to this and previous points to this. Still it is not matching, current points to this and previous points to this. Now if current is none, so it is not none because there is the required node is found. So what we are doing to bypass, previous next equals to current next. So what will be here? So what will be there at last node? Now what is happening? This is going to be bypassed. So to bypass, we are executing this statement. So what we are writing, previous next. Here we are storing none. That means it becomes a last node, it is bypassed automatically. So this same statement, which is taking care of general case, is also taking care of the special case when the node to be deleted is at the end. So there is no problem. If the node to be deleted is at the end, it is taken care by the general logic itself. The general logic is bypassing the node, found node, bypassing the found node if the required node is somewhere at the middle or somewhere at the end. Required node is somewhere at the middle. We are bypassing the node, then it is the same logic is taken care taking care of this special case, which is node to be deleted is at the end. So this is node to be deleted at the end, it is taken care. Now we'll check whether this is working fine or not, because we have not done any modification to the code. I'll execute this because the same code is taken care. Now I'll check whether it is working fine or not. So still we are running. I'll continue the same execution. So we'll see what are there. 5. So 10, 20, 30 we are going to delete. So 4 we are going to delete 30. So it should be deleted. There will not be any problem because it is going to be bypassed. So it says, and we have to display the message. I am not displaying. I'll display that. So now if you check 10, 20, it is coming, means 30 is deleted. Now again I will try to delete 20. It should be deleted without any problem. 20 if I take, so it is deleted. Now if I take 5, so it is 10 will be there, so it is taken care. So special case is taken care by the general logic itself. So I'll terminate this. So this special case is taken care by the general logic. So this this is the general logic. So this is general logic, means taking care of general case, and general logic takes care of special case special case of the law of the special case of node to be deleted, node to be deleted at the end. So this is taking care. Now, but I don't think this will take care of this special case. One more special case, which is when the required node to be deleted is at the beginning. Now we'll see what happens when it is at the beginning. So I'll take the list. I'll take the linked list. So the special case which we have to take care is special case is node to be deleted at the beginning. Means the first node itself. So node to be deleted at the beginning. So we'll take a linked list. So this is start. This is 10, suppose 25, 20. Now this is pointing to this, and this is pointing to this. Now what is the logic for deletion? I'll copy this again so that we confirm whether it is working fine or not. Now if I take this, so initially current is pointing to this. Now note to be, what we have to do here is I want to delete 10. So to delete 10, what we are making initially, previous is pointing to this and current is pointing to this. Now current not equals to none, true, not true, current data equal not equals to data, it is false. So the loop is terminated. The loop is terminated. So when the current data not equals to data false, so the loop is terminated. It comes here. It comes here. Now current is not none. It's false, but here previous next. So previous is this, and previous next equals to current next. So previous next equals to current next. Both are pointing to the same thing. Here what we are doing is we are storing this next. So current next, both are pointing to this, and it is not going to be deleted because previous is pointing to this, current is pointing to this. We are storing the reference of this node again into this, so there is no impact of deletion, so it is not going to be deleted. So this logic whatever we have written, this general logic whatever we have written, is not taking care of the special case when the node to be deleted is the first node. Now the first, so what we had to do, we had to slightly modify the logic. But first, we should know whether the node to be deleted is the first node or not. How do we know whether the node to be deleted first node or not? Several ways I can check. So what we can do is, if the node to be deleted is first node, then previous and current will be pointing to the same node. Previous and current will be pointing to the same node. Okay. So when it is same node, what we have to do, when previous and current is pointing to the same node, then it indicates that it is the first node. So when it is the first node, what we have to do is start should refer to the start should bypass this. So when previous and current equals to same, then what we have to do is start equals to previous or current dot next. That means the first node is bypassed. First node is bypassed. So that is the logic we have to write. So the logic what we can do here is, the logic here what we have to write is, so add one more special case. So else if current equals to previous. If both are same, then this is node to be deleted. Node to be deleted is the first node. So what we have to do when this is the case, so what we have to do is start equals to current dot next or previous dot next, because both are pointing to same. Otherwise, in other case, means generic case, we can write this. So this is working fine. But one more, there is a possibility of one more special case. But I think it is taken care. Another special case. See, here we have taken several special cases. That's how you have to write the data structure programs. Because sometimes some special cases, if you forget, then the program will fail. So what are the special cases we have considered? The special cases we have considered. So special case, we have taken special case node not in the list. Second special case is node to be deleted is at the end, that is taken care. Then the third special case is node to be deleted is at the beginning, that we have written the logic, and list is empty. And one more special case is when there is only one node, and that is deleted. One node and it is going to be deleted. Going to be deleted. So when it is only one node and it is going to be deleted, I think that is taken care, but you have to be careful. So all special cases you have to guess and write the logic. So for example, suppose if the list is this way, list is this and start is pointing to this, and this is 10 and this is none, and current is pointing to this, next is pointing to this, sorry, previous is pointing to this. Now I want to delete 10. So so current and previous are pointing to the same thing. So this will be under this, it will come current equals to previous. Now start equals to current next. What is there here? It will be none. So when the last node is deleted, so start equals to current next. So start is going to become none. That indicates that just now the last node is deleted. So there is no problem. This special case is taken care, but you have to be careful. This kind of special cases we may be missing, and it will give wrong result when we execute the program. So now this is taking care of all special cases. So this is the delete node with all special cases. Now we'll check whether everything is working fine. So I'll execute this. I'll execute this. I'll execute this. So the other options we have checked carefully. Delete will concentrate. So first we'll build the linked list. Then I'm adding Then 2 I'm adding 20, 3, 2 I'm adding 30, 2 I'm adding 40. So now I have added 10, 20, 30, 40. So if I take this, so there is 10, 20, 30, 40. Now first, what we'll do is we'll delete the last node. I think that is taken care already. We have checked it. We'll delete the node at the beginning. So now I'll say 4. I'll delete 10. So it should have been deleted correctly. Now we'll check. So it should be, it is not deleted. Some problem have I think have I not modified that? Okay, I'll check why it is giving why it is not getting executed. So if current equals to previous, start equals to current next, current equals to previous, start equals to current next. I think this is not executed. We'll execute it again. Maybe that changes might not have been impacted. So delete node if current equals to previous, current equals to previous. So node to be deleted is the first node. Okay, we'll check. I think I'm not calling delete. I'm calling. Yeah, it is called. So I'll execute this. I'll insert 10 to 20. Now I'll display. So 10, 20. Now I'll delete 10. So 4, delete 10. Now 5, it is not coming. Delete 10, why it is not getting deleted? Okay, we'll check what is happening there. So I'll display a message. Here I'll display a message, and here this is special case. I need not write because we'll stop if current equals to previous, start equals to current next. Then I'll say print uh, the node with data, the node with data, deleted successfully. Now we'll check why it is, what is the problem. Current equals to start equals to current next. It should be correct. So, okay, I'll execute this again. Now I'll execute this again. Now I'll execute this again. So I'll build the list 1, 10, 1, 5. So 5. So then I'll add one more, 2, 20. So 5. So 1, 10, 20. I'll delete the last node. So I'll say 4. I'll delete the node 10 now. We'll see. So node with data 10 is deleted successfully. Now if we say 55, 20, it's okay. Now when I say again delete node, if I delete 5, node with data 5 deleted successfully. Okay, understood. Here the mistake what I am doing is I am not using self. So temporary here I have to say self dot start. That is the mistake I am doing. Understood now. The problem here is I'm saying start here. It should not be start. It should be self dot start. If I use start, local variable start is going to be created. So that is the problem. Otherwise the logic is perfect. So we have to be careful. Now it should be okay. Now it is okay. So this kind of problems if you'll be encountering when you write some big programs. So now I think it should be perfect. So 10 I'll insert, I'll say 2, 20 I will insert, I'll say 2, 30 I'll insert. Now I'll display 10, 20, 30. So I'll now try to delete the first node. So I'll delete 10. So it is deleted successfully. Now if I display, so 20, 30, it is deleted successfully. Again, I'll delete last node this time, 4. So when I delete 30 now, it should be only 20. So when I say 5, it should be only 20. Now one special case, the node to be deleted is there is only one node and we are going to delete that. That is one special case and it is taken care automatically. So I am going to delete 20 now. So now if I try to display, it should say list is empty. So it is saying list is empty. So the deletion is working fine. It is taking care of all special cases.